All right, so I'm going to derive equations 3 through 5 all in one video because in equations 3 through 5, we're going to use 1 and 2 and manipulate them in order to solve for missing variables. So we have our first equation of kinematics, which is final velocity is equal to initial velocity plus acceleration times change in time. And we have our second equation of kinematics, which is that our displacement is equal to 1/2 final velocity plus initial velocity times change in time. All right, so my first question and what I'm going to derive when I look for equation 3 is going to be that I don't know, or I'm trying to solve a problem and I don't know what the final velocity is. I'm looking for final velocity. And I don't have that to plug in. So if there's more than one missing variable, I need to solve for the other missing variable, but I can't use an equation that involves final velocity. So in order to get rid of final velocity, what I'm going to do is I'm going to sub in this for final velocity in equation number 2. So that's what this looks like. So this is going to be equation number 3 of kinematics, and that marker showed up the same color, even though it's red, not orange. Let's see if purple shows up better. All right, at least it looks like black. All right, so I'm going to sub equation 1 into equation 2. So I have my displacement is equal to 1/2. This is where I'm going to put equation 1. So I have initial velocity plus acceleration, change in time, plus my initial velocity change in time. So all I did was take this and sub it in for the final velocity in equation 1. So now the first thing I'm going to want to do is distribute. So I have my displacement is equal to that's not the way I distributed first. I'm going to go this way first. Is equal to 1/2 2 initial velocities plus acceleration, change in time, times change in time. Now I'm going to distribute this way. I'm going to get that my displacement is equal to initial velocity plus 1/2 acceleration, change in time, all times change in time. And I'm going to get that my change in displacement is equal to initial velocity, change in time, plus 1/2 acceleration, change in time squared. What you need to know is that this change in time is the only thing that's squared. So acceleration isn't squared and neither is the 1/2, just that change in time. So we're going to use equation 3 to solve for an unknown when our final velocity is also unknown. All right. So let's look at the other two equations of kinematics. And we're going to use these final equations a lot, more than we're going to use equations 1 and 2. So equations 3 and 4 are where we're going to spend most of our time, but we'll also use equation 5. So let's look at equation 2. Or sorry, equation 4. So in your workbook, it would look like this. So this is the page we're on. So on my explanation, I'm going to say that it's similar to 3, and it's extremely similar to equation 3. You're going to notice when we finish, all that's different is a couple of changes in signs. Except that we're going to eliminate initial velocity instead of final velocity. So the first thing I'm going to do is write my two kinematic equations. I have up here kinematic equation 1 and kinematic equation 2. But I'm going to manipulate kinematic equation 1. And I'm going to isolate the initial velocity. So up here we have final velocity isolated. Down here, I'm going to put initial velocity isolated. So I'm going to say that my initial velocity is equal to my final velocity minus acceleration change in time. Now I'm going to do the same thing I did before to solve. So I'm going to say that my displacement is equal to 1/2. I'm going to leave final velocity because that's what I'm eliminating initial, not final on this one. And then I'm going to sub in 1 right here. So I'm going to say 1/2 plus final velocity minus acceleration change in time all times change in time. All right. First thing I'm going to do is simplify this. I'm going to get my displacement is equal to 1/2 times 2 final velocities minus acceleration change in time times change in time on the outside. If this helps up here and I didn't put my parentheses, there we go. So this is where I'm distributing first. Going this way with it. Now I'm going to distribute this 1/2 through. So I'm going to get that my displacement is equal to final velocity minus 1/2 acceleration change in time. I'm going to distribute my change in time throughout, and I'm going to get my displacement is equal to my final velocity times change in time minus 1/2 acceleration change in time squared. And again, the only thing we're going to square is that change in time. So we're going to use this equation to solve for an unknown. When initial velocity is also unknown. All right, now we need to derive equation 5. So it's going to be the last equation we're going to look at. And I need a clean sheet of paper, so excuse me. All right, I've switched to my clean sheet of paper. So I know that my first kinematic equation says that final velocity is equal to, I always want to draw a triangle instead for velocity for some reason. Initial velocity plus acceleration times change in time. We know that kinematic equation 2 states that my displacement is equal to 1/2 final velocity plus initial velocity change in time. All right, so when we solve for kinematic equation 5, it's going to be similar to equations 1 and 2, or 3 and 4, and except this time we want to eliminate change in time. So our change in time is unknown. So this time we're going to sub 1 into 2 at change in time. All right, so let's go ahead and work through that. So this is kinematic equation 5. I have that my displacement is equal to 1/2 final velocity plus initial velocity times final velocity minus initial velocity, all divided by acceleration. And you're like, okay, Miss Neal, where did that come from? I rearranged kinematic equation number 1 to solve for change in time. So I have velocity initial on this side, and I'm going to bring it over. So that gives me velocity final minus velocity initial. I'm going to divide by acceleration to isolate that. And that's going to equal change in time. So that is what I put down here. Because remember, we wanted to eliminate change in time. So I solved for change in time and then substituted it into equation 2. So at this point, all we have to do is simplify the equation to make it look prettier. I want to get this 2 out the bottom and this acceleration out the bottom. That's my first goal. So I'm going to put 2 times acceleration times change in displacement is equal to velocity 2 plus velocity initial times velocity 2 minus velocity initial. And you should notice that the right side is a difference of squares. So we've got a difference of squares here. And in math at some point, hopefully you learn that a plus b times a minus b is equal to a squared minus b squared. So we're going to do that same thing over here. So we're going to get 2 times our acceleration. Displacement is equal to our final velocity squared minus our initial velocity squared. I like to make sure and use an F here just so I don't get it confused with the subscript. But if you want to continue to use the 2 here, that is completely fine with me. All right. And now I want to clean it up a little bit, and I want to isolate just one variable on one side. And the variable that's been chosen is final velocity. So my final velocity squared is equal to my initial velocity squared plus 2 times acceleration times displacement. So there's my last equation of kinematics. So when I don't know change in time, so when change in time is unknown, and I also need to solve for one of these variables, I can use this last kinematic equation. And to make life easier, this is one of my favorite charts. If you flip back in your notebook, right here, it has all 5 of your kinematic equations, and then it has the variables that are missing in each kinematic equation to kind of help you out. And that's all I have for today.